In the previous video, we did Lewis dot structure that fulfilled the octet rule or were less than the octet rule. This video will focus on Lewis dot structures that exceed the octet rule. Draw the Lewis dot structure for PCl5 and SbI5 and then check your answer. Phosphorus has 5 valence electrons plus 5 chlorines, which each have 7 valence electrons with a total of 40. Central atom is going to be phosphorus, which is the least electronegative with the chlorines around it. So I'm going to spread out the chlorines. Each of the chlorines already have 2 electrons from the bonds, so it needs additional 6 to fulfill the octet rule. The central atom phosphorus already exceeds the octet rule, and it can because it's in periods 3 through 7 and they have empty d orbitals. So if I count the number of electrons in the Lewis dot structure, it equals 40 electrons. It matches the total valence electrons, so this is a correct structure for PCl5. Sb has 5 valence electrons plus 5 iodine, which have 7 valence electrons each. So this is also equal to 40 electrons. The least electronegative element goes into center, which is Sb, and then the i's will be spread out on the outside. Each of the i's, or iodines, have 2 electrons from the bonded pair, so everything else needs 6. Antimony already exceeds the octet rule, and it can because it's in energy levels 3 and above, and it has those empty d orbitals. If I count the total number of electrons from the Lewis dot structure, it is 40. It matches the valence electrons, so this is the correct structure, SbI5. We're going to look at the central atom of phosphorus. There are 5 bonded pairs, 0 lone. If I look at antimony, I have 5 bonded pairs, 0 lone. There's 5 bonded, 0 lone. The general structure, with B being the center atom, and have the outside elements. These can be the same elements or different elements. A 5 and a 0 is trigonal bipyramidal. You could think of 2 pyramidal shapes that are placed on top of each other. Since there is no lone pair, because molecular geometry accounts for lone pairs, this is also trigonal bipyramidal. The angle is going to be 90 degrees and 120. If I redraw the structure, what it looks like is P is in the center. We have a Cl on top. We have a Cl kind of on the bottom. And then the other 3 Cls are in a plane and they make a triangle. So the Cl on top to the plane, which is a triangle, makes a 90 degrees. And the angles between the Cls in the triangle plane is 120 degrees. Pause the video, draw the Lewis dot structure for the 2, and then check your answer. Te has 6 valence electrons. There are 4 fluorines, each with 7, total of 34 electrons. Central atom is the least electronegative, which is Te. The fluorines are going to spread out. Each of the fluorine has 2 electrons from the single bond. It needs 6 more. Beryllium has 4 bonds, so it has 8, and everything has octet rule. The total of electrons from the Lewis dot structure, there are 32 electrons, but there are 34 electrons in the valence. So I am missing 2 electrons. If I draw all single bonds, that is the maximum electrons I can have. So the extra 2 electrons must go to the central atom. Te can exceed the octet rule because it's in periods 3 through 7, which have d orbitals. So when I count, now I have 34 electrons, which matches the total valence electron. Sulfur has 6 valence electrons plus 4, and each of the bromines have 7. So this is a total of 34. Central atom is sulfur. The bromines are going to go on the outside. These are all BRs. BR each all have 2 electrons from the bond, and so it needs 6 more. Sulfur has 8, so it fulfills the octet rule. So now if I count electrons in the Lewis dot, I will have 32. This structure is not correct because I have 34 valence electrons. I am deficit 2 electrons, and since sulfur is in period 3, it can hold the extra 2 electrons. If I look at my central atom Te and S, they both have 4 bonded pairs and 1 lone. 1, 2, 3, 4 bonded, 1 lone. Same goes for sulfur. So the bonded pair is 4, the lone pair is 1. The general structure, central atom is B. We have a lone pair on top, and then we have 4 elements on the outside. They could be the same element or different element. Since electron pair arrangement doesn't account for lone pairs, 4 plus 1 is 5. Therefore, the electron pair arrangement is also trigonal bipyramidal. We have 1 lone pair. Molecular geometry cannot be trigonal bipyramidal. It is seesaw. The reason it is seesaw is if I look at Te, we have a lone pair on top. We have bonded pairs, 4 of them. This pushes my bonded pairs down, and you could think of the lone pairs as a pivot point, and the bonded pairs can shift up and down. Since the lone pairs exist, my angle is going to be less than 90, and it's going to be also less than 120. Pause the video and draw the Lewis dot structure for BRF3, and then check your answer. Br has 7 valence electrons. There's 3 fluorines, each with 7, total of 28 electrons. Br is the central atom because it's the least electronegative. We have fluorine, 3 of them. Since it has a single bond, it has 2 valence electrons. It needs 6 more. Same goes with the other fluorines. The fluorines fulfill the octet rule. Bromine has 3 bonds, so it has 6, so it needs 2 more. If I count, I'm going to have 26 electrons in the Lewis dot structure. However, I need 28 electrons, so the structure is incorrect. I am deficient 2 electrons, and the 2 electrons will go to the central atom. Draw the Lewis dot with single bonds and fulfill the octet and duet rule. And I have less than the total valence electron. That means the remainder must go to the central atom. So if I look at Br, the central atom, it has 3 bonded pairs, 1, 2, 3, and it has 2 lone pairs, 1, 2. General structure with the central atom B will have 2 lone pairs, and then will have 3 elements on the outside. Since the bonded and lone pair add up to 5, the electron pair arrangement is also trigonal bipyramidal. However, the molecular geometry will not be trigonal bipyramidal because we have to account for lone pairs. So if I look at the bonded pairs, it makes a T shape. Geometry is T-shaped. And since it's double the lone pairs, my angle is going to be less than 90 and 120. Pause the video, draw the Lewis dot structure for XeF2, and then check your answer. Xe has 8 electrons. There are 2 fluorines, each with 7. A total of 22 electrons. Central atom will be Xe. The fluorines will be on the outside. Each of the fluorine has 2 electrons from the bond, so it needs 6 more to fulfill the octet rule. Xe has 4 electrons from the bonds, and so it needs 2 more to fulfill the octet rule. If I count, I have 20 electrons from the Lewis dot. and I need 22 electrons. So my Lewis dot is incorrect. I am deficient 2 electrons. The 2 electrons must go into the central atom. So it's going to look like this. So if I look at the central atom Xe, there's 2 bonded and 3 lone. The general structure with the central atom B will look like this. 3 lone pairs. They're going to be arranged in a triangle. They are in the same plane. And then we have the elements on the outside. 2 plus 3 is 5. So this is also trigonal bipyramidal for the electron pair arrangement. However, it has lone pairs, 3 of them. And if you look at the elements that are bonded to the central atom, they form a line. So the molecular geometry here is linear. And we are going to have 3 angles. We're going to have 90 degrees because that is from the bonded pair to the lone pairs that are in the triangular plane. The lone pairs are separated by 120 degrees. And then the bonded pairs are separated by 180 degrees. So all the structures we just did are all trigonal bipyramidal because the electron pair arrangement, if I add the bonded and lone pairs, they add up to 5. Remember, electron pair arrangement does not account for lone pairs. However, the molecular geometry will change. The more lone pairs it has, the closer the bonds are together. Except for linear, they will be in opposite sides. The angles are all 90 and 120. Even seesaw and T-shape, you can memorize it as 90 and 120. The last one that is linear, you must also add the 180 degrees for the bond angle between the bonded elements. Pause the video, draw the Lewis dot structure for SF6, and then check your answer. Sulfur has 6 valence electrons. There are 6 fluorines, each with 7. This is 48 electrons. Central atom is sulfur with the fluorines around it. Each of the fluorine has a single bond, so that means it has 2 electrons and it needs 6 more to fulfill the octet rule. The sulfur in the middle has 6 and it could exceed the octet rule because it's in period 3. Count the total electrons in the Lewis dot structure. It is 48. So this structure is correct because it matches the valence electrons. It has 6 bonded pairs and 0 lones. The general structure is central atom B. You have 6 elements around it. 6,0 has an electron pair arrangement called octahedral. Since it has no lone pair, it is also octahedral. It is called octahedral because if we look at it in a 3D plane, it has 8 faces. The angle between any of the elements that are bonded is all 90 degrees. Pause the video and draw the structure for BrF5 and then check your answer. Br has 7 valence electrons. There's 5 fluorines, each with 7 valence electrons. So this is going to add up to 42 electrons. Central atom has to be Br because it's the least electronegative. And then we're going to have 5 fluorines on the outside. Since each of the fluorine has a single bond, they have 2 electrons, so I need 6 more. My central atom bromine has 5 bonds or 10 electrons, and it could exceed the octet rule because it's in between periods 3 and 7. So now if I count the total number of valence electrons, there are 40 electrons in the Lewis dot structure. My calculated valence electron was 42. So that means I am short 2 electrons and they must go to the central atom. So if I look at my central atom bromine, it has 5 bonded pairs. 1, 2, 3, 4, 5. 1 lone pair. The general structure is B, the central atom will have a lone pair and then it will have 5 elements on the outside, and they could be any elements. They could be the same or they could be different. Since 5 plus 1 equals 6, my electron pair arrangement is also octahedral. Remember, this is not accounting for lone pairs. However, my molecular geometry is not going to be octahedral because there is a lone pair, square pyramidal. And the reason so is we have a lone pair on top, we have fluorine on the bottom, and my other fluorines, they make a square, and then if I connect it, it makes a pyramid. So the fluorine on top is the apex, and the 4 fluorines are in the same plane, so it makes a square pyramidal. So the angle is a little less than 90 degrees, but you can memorize 90 degrees because the lone pairs will bend the bonded pairs closer together. Pause the video, draw the Lewis dot structure for XeF4, and then check your answer. Xe has 8 valence electrons plus 4 fluorines times 7 valence. So this is going to have a total of 36 electrons. Central atom is the least electronegative, which is xenon, fluorine on the outside. Each of them have a single bond, so it has 2 electrons. So it needs 6 more electrons to fulfill the octet rule. Xenon already fulfilled the octet rule. It's happy. So now I need to count the total number of electrons in the Lewis dot structure equals to 32. The valence electron is 36. So this structure is deficit or deficient 4 electrons. The 4 electrons must go to the central atom. And if I count now, there is 36. So this is the correct structure for XeF4. So if I circle my central atom, I have 4 bonded and then 2 lone. My generic structure is B is my central atom. I have a lone pair on top, a lone pair on bottom, and then I have my bonded pairs spread out. 4 plus 2 is 6, so this is also octahedral. We don't account for lone pairs when we do the electron pair arrangement. My molecular geometry is square planar. My fluorines are all in the same plane and they make a square. My angle is going to be 90, and also I have 180 degrees from the lone pairs, but you only need to know it's 90 degrees. So summarizing the octahedrals, if they add up to 6, the bonded pairs plus the lone pairs, the electron pair arrangement is the same. So these are all octahedrals because it doesn't account for lone pairs. The molecular geometry is different. If they have no lone pairs, it is the same as the electron pair arrangement. The other ones, as we gain more lone pairs, their shape changes to square pyramidal and square planar. For the angles, you just need to memorize 90 degrees. You must memorize this table for the test. Add up your valence electrons correctly. Least electronegative goes in the middle. You start with single bonds. If single bonds don't work, you do double, you do triple. Fulfill the octet and duet rule. Note, hydrogen can only have 2. B and Be will tend to have between 4 and 6. Periods 3 to 7 can exceed the octet rule. Ions must take brackets with the charge on the outside. Anything that has a resonance structure, you must draw. Formal charges calculate when they are asked for, and always remember to recount. If you start with a single bond in the Lewis dot structure exceeds the valence electron, subtract and divide by 2, and that will give you the number of bonds needed to be added to the Lewis dot structure. If you start with a single bond and the Lewis dot structure is has less electrons than the valence electron, then you must add missing electrons to the central atom, and make sure you recount and draw your dots correctly.